Remember what the reciprocal of 2/3 is? 3/2, yes. The numerator becomes the denominator becomes the numerator. What's the reciprocal of 4? Thank you, 1/4. Two numbers whose product is 1 are called reciprocals. That's the true definition of a reciprocal. So 4 times 1/4 is 1. 2/3 times 3/2 is 1. Okay? So we're going to figure out what negative powers do to the number. Anybody tell me what 2 to the power 5 is? 32. 2 to the power 4? 16. 2 to the power 3? 8. 2 to the power 4? 4. 2 to the power 1? 2 to the power 0? 1. We learned that in grade 9. Now for the new stuff for grade 10, negative exponents. What do you think if you look at this pattern? If I'm going, do you see I'm going down in the exponents, down by 1 each time? What's happening to my value? Can anybody give me a guess of what 2 to the power -1 would be? I hear -2. Anything else? Just 2, like it goes back up. Look at the pattern going on here. Come on, superstars, I want to hear. Huh? Nobody can tell me. Come on. We're not, no, it's not. It's not -2. It's not 2. Huh? Is it what? No, not 0.2. Sam? So how did you get 0.5 out of that? You're right. But I wouldn't say it as 0.5. I'd say it as 1/2. Who said that? Oh, you should say louder. Okay, so look what's happening each time. What happens when it goes from 32 to 16? What did it happen? It halved it or divided by 2 each time, right? It divided it by 2, divided by 2, divided by 2, divided by 2, divide by 2. What's 2 to the power -2? 1/4. Okay, just so you know, what's actually happening here is although the values are dividing by 2 each time, if you look solely at the actual exponent, do you see that this is really 1/2 to the power 1, and this is really 1/2 to the power 2? So now, can you conclude what the negative exponent is actually doing and why I started off with reciprocals to begin with? Watch this. So can we explain it in words here? When you have a negative exponent, you use the reciprocal, and what happens to the exponent when you do the reciprocal? It becomes positive as a reciprocal, and then we can actually evaluate it like that. Did you have a question? It would be 1/8, yes. 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 Okay. So that's the thing that you have to get out of this lesson today, is when x is any non-zero number and n is a rational number, then x to the power -n is the reciprocal of x to the power n. Meaning, if I have x to the power -n, if I make it the reciprocal 1/, that, then the negative exponent becomes positive. Likewise, if I have a negative exponent in the denominator and I reciprocate it, it'll become the positive exponent. Okay? This is huge. A lot of people have trouble with this because they make the mistake thinking that this -3 is an actual negative number, but it's not. It's a negative exponent. Okay? So, How are we going to evaluate this? We need to evaluate it by making the exponent positive. So how could I make the positive exponent out of 5 to the negative 3? Again, it's not a negative number. You're not listening to what I'm saying. You have to reciprocate it to make the exponent positive. So I reciprocate 5, it becomes 1 over 5, and as a result, that negative 3 becomes a positive 3 exponent. Now I can actually evaluate it. And what's 5 to the power 3? No. Yeah, 125. So it's 1 over 125. Yes? All right, next one. This is 1,000 to the power negative 2. So we reciprocate it to become positive. So that means it becomes 1 over 1,000. And then the exponent becomes positive 2. Now we're going to evaluate it. 1,000 squared means 1,000 times 1,000. So what do we get? No calculator. What do we get? 1,000,000, yes. Essentially, if you're multiplying by powers of 10, you're just moving the decimal place or adding the number of zeros you have. So do you see if you have 1,000 times 1,000, you have 6 zeros there, right? Okay, so now this is 3 to the power negative a quarter. 3 to the power negative a quarter. So what are we going to do there? Yes. So I think the way it's supposed to be written, I think something got glitched in this. Sorry, this line is not 3 to the power negative a quarter. It should be 1 over 3 to the power negative 4. Sorry about that. Because it wouldn't make sense otherwise. Okay, so I'll rewrite it just so you can see it better. 1 over 3 to the power negative 4. That's what the question is. It got a little glitch in the type. That line should extend there. For some reason it didn't. But anyways, so again, in order to make the exponent, in order to evaluate, your exponent has to be positive. So how do we make it positive? We reciprocate it. So because this is in the denominator, well, the reciprocal now will be in the numerator position. I could put it over 1 if you want. But then this is 3 to the power 4, which is 81. The biggest mistake I see students make is they think the negative exponent means that the number is going to be negative in the end. Okay? So get that out of your head right now. The only way you can evaluate negative exponents is make it positive and then evaluate it, right? Okay, so now we're going to bring in yesterday's lesson with today's. Okay, so this is going to get crazy fast. Okay, so in order to make this a positive exponent, right, what do we have to do? We reciprocate 16. So now this is going to be equal to 1 over 16 to the power 3 over 4. Is everybody good with what I did so far? In order to make the exponent positive, I reciprocate it. So that's always the first step. And then yesterday's lesson, we learned, what do we do first? The rooting or the powering? The rooting. So we need to find the fourth root of 16. Does everybody see this represents the fourth root of 16? So if you want, I can write it like this. You do not have to show this step, but I'm just showing what I'm going to do. This is going to be the fourth root of 16 to the power 3. Does everybody see? That's what you did for homework last night, essentially, is rewriting, say, 16 to the power 3/4 and then evaluate. So what is the fourth root of 16? It's 2. So this is going to be 1 over 2 to the power 3. So then my final answer is going to be 1/8. Do you see how this is going to get crazy fast? Because now we're putting two things together now, right? Okay. 27 to the power negative 2/3. So what is the first thing we have to do? We need to make that negative exponent positive by doing 1 over 27, yes? So that is to the power 2/3. And then what do we do first? We do the root first, then the power. So we need to do what to the 27? Cube root it. Does everybody see this is the cube root? That's why the 3 is on the bottom. It's a cube root. Are we good? Again, this is what we did for homework last night. So I'm going to write this step, but you don't have to do this. Some people can just do it fast. It's one mark, done, right? So this is the cube root of 27 to the power 2. That's what you were practicing for homework last night for the first couple of questions, right? It's just rewriting it as radical with powers. So what's the cube root of 27? 3. So then this becomes 1 over 3 squared, which becomes 1 over 9. Okay? Again, if you can see, once you get really good at this, you can go from 27 to the power negative 2/3 to 1/9. Like, you don't have to show any of the intermediate steps as either right or wrong. Okay? But I'm saying to you, when you're learning this process, you should probably do each step just to get through your head where you're going. And then if you make a mistake, then at least we can see where you made a mistake. Is there a question? Okay, let's do the next one. This is 49 to the power negative 3 over 2. First step, write it as 1 over 49 to the power 3 over 2. Yes? What does the 2 in the bottom mean? Square root. So this is 1 over the square root of 49 to the power 3. So then this is 1 over 7 to the power 3. And do we know what 7 to the power 3 is? I'm sorry? 343. Yeah. So 1 over 343. You must have pressed something wrong in there or something. Okay. To write the reciprocal of a fraction, transpose, oh, I don't even have that. Transpose the fraction. Okay, what do I want there? To write the reciprocal of a fraction, transpose the blank and blank. I'm going to say transpose the fraction, the numerator and the denominator. That's what I want to do. The numerator and the denominator. That's essentially what you're doing when you're reciprocating. You're flipping the numerator and the denominator, except all of these had 1 as the denominator. So that's why it became 1 over. Now we're going to actually have fractions. So what I'm trying to say is, if I have a fraction that's a over b, if I transpose the numerator and denominator to b over a, then that negative exponent becomes positive. Anytime you reciprocate, the negative exponent becomes positive, okay? So do you see, when I went from 49 to 1 over 49, the negative 3 over 2 became positive 3 over 2. Yep. Yes, if you transpose it, then it would go to negative. And there's no point of going to negative exponents because you can't evaluate it that way, right? But they might have some coming up that they'll say, you know, whatever. Okay, so again, first step is to get the negative exponent positive. How do we do that? We reciprocate it. So in this case, it's not a whole number that we're reciprocating, so it's not going to be 1 over that number. The 2 over 5 is going to become a 5 over 2, and that would automatically make the exponent positive 3. Do you see how it works with a fraction? So somewhere in grade 9, you learned that this whole thing, and by the way, if you just put a 3 without the brackets, you will lose an error code because it's intended, the 3 is intended to both the numerator and the denominator, right? So that's what I was trying to go with. In grade 9, you learned that if a fraction is to the power 3, the 3 goes to the numerator and the denominator. So then what is my final answer?
125 over 8.
Very good. 125 over 8. Excellent. Okay, so now let's go to the next one. 7 over 5 to the power negative 2. So reciprocate, then the exponent becomes positive. So 5 over 7 to the power positive 2. Yes? Then evaluate that, and what do we get? 25 over 49. Excellent. Okay, let's do, oh, okay, sometimes it tricks you, right? Okay, so first step, reciprocate. So this becomes 3 over 4 in brackets to the power 3. Yes? So then we get 27 over 64. And so I don't think there's any factors that you can reduce that with, right? Okay. So for some reason, it wants you to do the calculator to evaluate this. So 16 times 4 is 64, yeah. Okay, so you guys want to try this? It's what? Okay, you guys have a fancy calculator, and you should be able to punch it exactly the way in. The only thing I would suggest is to maybe use brackets around this so then it knows it's to the whole power negative 3. If you don't have a fancy calculator, you'll have to do the same process and reciprocate, then do to that power. It looks like you should get 1.953125. Is that what you got? This one is an irrational number, so I'm only going to write the first few digits of it, so that you should get 0.34602, blah, blah, blah. So that one I'm truncating after so much, but yeah. So you go 1.7. There's a little hat dealy on your graphing calculator that looks like that. Yes? Did you find it? And then I'd probably put brackets around the negative 2.
I don't know how to use this.
There.